Comment and subscribe.
Okay, so this is the last new topic before our test Thursday. And what we're going to look at can go by a couple different names. Vertex edge graphing, directed graphs, digraphs. All these, it can be called any of these. Now what you see on your notes, this first thing is a digraph, and it's representing the travel routes between cities. And this ought to make sense for the Peachtree City crowd, because you guys fly more than I do. But this could represent flying from city to city, maybe Atlanta and Baltimore and Cleveland and
Detroit.
Detroit. Okay, I like all
From
those.
the A to the D.
Detroit, Cleveland,
Boston.
Boston.
Boston. You'd rather have Boston?
Oh.
Okay. Atlanta. All right. So,
What the heck? You built off like the letters we've never seen the other one.
What?
So you should have had Atlanta end with the A.
That's smart.
I like that.
You gotta make them all capital though.
Do not. All right. So, Atlanta, Boston, Cleveland, Detroit. So this graph could represent. So what this looks like is we can fly directly from Atlanta to Boston. But to get to Cleveland, we can't fly directly there. We would have to fly through Boston,
That's
your
pretty
layover,
correctly.
and then go to Cleveland.
Yeah,
Okay, I know that technically this is not the way it would work. We randomly pick some city names. It wouldn't be very bright to go to Boston
Yeah.
and
Detroit
then
is
go
not
to
south.
Cleveland. I get that.
Other way.
Okay? So, which cities can you travel directly from city A? So from A, we can go where? We can go to B, and we can go from A to D. All right. From Boston, where can we travel directly? C, and we can also go to D. All right. From Cleveland, we can travel directly to Boston and D. And then from Detroit, we can travel directly to Atlanta. And that's it. Okay? So, can we take this and turn this information into a matrix? Well, we sure
Probably.
can.
No, because we don't
Okay.
have numbers.
If a direct flight is possible, we will represent that with a 1. If it is not possible, a 0. Okay? So, this is not hard. This is where we're going from. We'll put down this, label our rows, and where we're headed to, we will label our columns.
What if it's the place? Like, what would you do for AA?
Is it possible to go from A to A?
Yes, it is.
Why would you do that?
No.
What, you're like already in the city.
Exactly.
Why would you fly to the
All right, now, is it possible to get on an airplane, get up in the air, and have to turn around and go back?
Yes.
Yes, but not according to our diagram.
It's not practical.
Okay? So for that to happen, we would have to have a little whoopsie arrow. Okay?
Whoops.
Yeah. I don't want to be on that flight. No, thank you. Okay. So, but we can go to Boston and Detroit, but there's not a direct path to Cleveland, according to our little made-up schematic. Okay. So do you see how it works?
Binary.
All right, you finish out. You finish the matrix for us then.
It is not binary.
It's close enough. It's a bunch of zeros and ones.
Ooh.
You sure can. Just slide the back.
Now we switch these so there's ones down the diagonal. We solve
Well, that's an interesting thought. We're not going there with it, but that's an interesting thought. Whoops, D to A is my only possibility. Okay, so is my matrix correct? I did it really fast. Does yours match mine?
Yes.
Okay. All right, so this matrix actually represents that graph, doesn't it?
Sure.
So could we start with a matrix and create the graph? Yeah.
Fair enough.
Okay. And I'm going to ask you to do that on some of the problems in a minute. Okay, now, suppose suppose you are perfectly happy with a layover. That is not me. I don't enjoy flying because you give up control. So, I don't enjoy any mode of transportation where I'm not stuck. So I avoid layovers, but sometimes it's not possible. There are some places you can't get to without stopping on the way. So, but if you are one of those people, and many of you may be because you fly a lot, and you're perfectly happy with a layover, how many different routes would there be from city A? Okay, so if we were okay with a layover, we could go from A to B, and then B to where?
D.
D, okay? We could go from A to B, and then B to where? C. We could go from A to D, and then D back to A.
That's fun.
All right? So now you do the same thing with B and C and D. List all those possibilities.
I thought there's an easier way to do this.
You're about to find out.
Yeah, this reminds
Well,
me.
yeah, I feel like
What?
you're
Like
talking
the-
about you're gonna be like, oh, and this is the easier way.
Like what,
Like
like
the
trade
line.
diagrams? Is that what it's called? Where it's like you look at different options.
We did those with probability, didn't we? Yeah.
That's what it's like.
It is, because right now we're listing all the possible outcomes, and then we're just gonna use matrices to make our life so much easier.
One of them's dab.
So it is that. He's right. What am
Anytime you're writing the letters A, B, C, D, and
That can happen.
something.
Alright.
Whoa, wait,
So-
what? Whoa.
I'm not even
Jab and dab.
Wait, you said
No, stop.
You said when and what?
Yeah.
Obviously, he was just
Okay.
kidding.
So we can go B to C and back to B. We can go B to C and then to D. We can go B to D and then to A. Are there any other possibilities from D? From B?
Of course not.
All right, let's look at C.
Wait, there's no other possibilities?
No.
Do you have something else from B?
From B,
Okay.
that's an F.
All right, so from C, we can go to B and then to D. From C, we can go to B and back to C. From C, we can go to D and then to A. Is that it?
Yeah, that's all this.
Dad and dab.
Okay, so from D, we can only go to A, but from A, we can go to B, or we can go back to D. Okay, now, I would like you to do the same thing. Now, our first matrix, this matrix here, this represented a direct path, no layovers. Okay, now, this one is not, in 4, we're supposed to do a matrix of this one. So our matrix is no longer a direct path, but our matrix represents a layover. Because we're talking about air travel. So this is like a 2-step, not a direct. Whereas this one was a 1-step. A 1-step path. This is a 2-step path. Okay, so once again, we'll have our rows be our departing city, where we're starting from, and then our columns represent the ending, where we land, departure and arrival, final arrival.
Are we mixing 3
Okay.
different matrices?
So we have 1, 0, 1, 1 for the first row. Is that what you got? A to A. We have 1 that goes from A to A. We have 1 path that goes from A to C. And we have 1 path that goes from A to D.
True enough.
Okay? Now, it could have been possible that there were more than 1 path that went from A to A. depending on how our digraph is set up.
Yeah.
Like if this had arrows at both ends, that would mean I could go from B to D or D to B.
So you put 2.
So there could be 2 paths sometimes that take you from one place to another. Okay, so let's look at B. B to B, B to A, B to D. There's no B to C.
C to A.
Okay? C, we got C to D, C to C, and C to A, but no C to B.
ACDs?
Yeah. And then D, we have D to B and D to D, but no of those.
Oh.
Okay, so does your matrix look similar to mine?
1 0 1 1
Cool. Alright, so what I'd like you to do is go back and enter this matrix as matrix A into your calculator. Your one-step matrix as matrix A.
I got a graphics calculator.
Get excited.
0 1
got this.
0
Get it together.
It's already entered.
I
Yeah.
don't know.
I want the one that's already in there.
How do you get Let me guess for the second.
Normally I just type over matrices, but if you want to delete matrices, you can always delete matrices in a memory. So if you want to delete them, you go second memory and choose matrices and delete them.
Where's memory?
Plus, second and the plus sign gets you into the memory, and you can arrow down the matrices and you can delete them there. I usually never delete them, I just type over them.
Wait, where are they? I'm guessing they're all.
There's a matrices choice under memory. Okay. Does everyone have this entered into matrix A? Okay, so this is the one step, like a first power. This is a 2-step. I would like you to square matrix A.
Whoa.
You entered matrix A. We called this one A. I would now like you to square matrix A.
For matrix.
You lost me.
It's this.
If you square a signal with the exact same.
Now they're like 2.
Square the matrix?
One square 2.
Okay, so when you took the direct path and you squared it, what the resulting matrix is the 2 steps,
That's impressive.
isn't it?
If you were to do
So,
Alright, so now let's
if
go
you
over
were to
why
want to
it
know if we had 2 layovers,
then you would do it with the
you would do it to what power?
third.
The third.
And then we have 3.
Yes.
Could you do it from the 2-step and square that one to get the third? Or
No, if we squared a square, it would be a 4th.
Why did I get 2? If you cube A, you get 2.
We square.
Okay, so he cubed it, and we got a 2. So what that means is, where's your 2? In which position?
In row 1, 2.
1, 2, so from A to B?
Yes.
Okay, so what that means is, when there's a 2 now, instead of there being just one way to go from A to B with 2 layovers, there's actually 2 different ways to go from A to B with 2 layovers. That's why there's a 2 there. It's not just possible, it's possible 2 different ways. So there's not just one path with 2 layovers, there are 2 paths.
so it'd be like A to C to B and then A to D to B.
Yeah,
That's the 2.
2 different places to get to the same, yeah.
But you can't take the square BCB. It's the same like
Okay. Oh, there we go.
An A to B to D.
Okay, so, I do want to draw one with you really quick. You know what, I can do this without giving you this. I'll give you this next. Go ahead and flip your notes over. And let's say we had, I'll just do a small one, ABC. And then we had 0, 1, 1. and then we had 1, 1, 2, and then we had
2,
1,
3.
1, 0.
I don't.
So it's the number of
Okay,
ways that you
so what I do, guys, when I have one of these paths that I have to draw, where you start off with a matrix and you have to create, I like symmetry, so I always create a regular polygon.
Oh, so were you
So this time I'm making a triangle. If it were 4, I'd make a square. If it were 5, I'd do a regular pentagon. Okay? So you start by putting your letters down. Alright? If it's a test, I may start by putting the letters down for you, so I don't have to go nuts trying to grade them. Okay? Now, A to A. A is not going to A, so there's no loopy-loop. Okay? A does go to B. A to B.
How do you know whether this is a layover one or not?
This is not.
Doesn't it have to
How do
be?
you know?
This is just a directed path. We're not talking about
Will you
airplanes
tell
anymore.
us when it's in a
Sure.
directed path?
Well, how do you get it?
Okay? Now, A also goes to C. Okay, so all I did was create the first row. Alright, the second row
B to
says B goes to A,
And B to B.
okay? And A went to B, didn't it? So could I do it like this? A goes to B and B goes to A?
Oh, of course.
Because they go to each other.
Whoa.
I think you can do that.
You go to.
Okay? Now,
He said
B
wall.
goes to B. Loop-de-loo.
How do you, oh, C goes
Alright, and B goes to C.
Twice.
2 times. 2 times. 2 times. It's actually 2 times.
Alright, so C goes to A. Can I just put that?
Yes.
Alright, C goes to B once.
Just
Go
go back.
back.
One of them.
So there's, you could do that,
I'm
or I could put,
one doubles.
and then C doesn't go to C.
This is kind of weird.
It's easy.
It's weird, but I kind of like it.
Rap grid.
Okay,
I like
alright, so that's what our practice is today. Now, part of it is setting up matrices, part of it is setting up the graph, and then the rest of it is kind of application. Like the first problem is how our rumor spreads. So some people are receivers of the rumor, but they're good people and they don't spread it. So they just receive. Some people are receivers and get excited and they spread the rumor. So, then we have some that just spread. Okay, the next problem is about ships sending messages to other ships. And the last one is kind of a famous problem. It's about a bridge. Oh, it's about multiple bridges. And can you go from here to here without going over a bridge more than once?
By flying.
Okay? So, one of the problems talks about nodes. So the nodes would be, like, you know how we had the dots? Those are the nodes, yeah. The A, B, and C. That's a node. That's a node. That's a node. Okay? And that's it.